Okay, guys, so welcome back. Today we are looking at permutations and combinations, specifically focusing on questions relating to words. Okay, so let's look at this question here. This question says, find the number of different arrangements of the 9 letters in the word happiness. Okay, so you must remember, if you have n distinct objects, if you want to arrange them, you will have 9 factorial ways of different arrangements of arranging those letters. So that means here I have 9 factorial ways of arranging these letters. If all of them were different, I would have 9 factorial ways of arranging them. But I have repeating letters. I have 2 P's, I have 2 S's. So I need to remove those, the repeats. So I need to remove the repeats by dividing. So I'm going to divide by 2 factorial for the repeating P's, and then I'll divide again by 2 factorial for the repeating S's. So this will give me 9 factorial divided by, so I have 9 factorial divided by 2 factorial, that will be 4. So this gives me 90,720. So I will have 90,720 different ways of arranging these letters. Now it says, find the number of different arrangements of the 9 letters in the word happiness in which the first and last letters are not the same as each other. So the first and the last must not be the same as each other. I think it will be easier for us to look at situations where the first and last letters are the same, and then we subtract from the total arrangements. Okay, so I can say I could have this situation 1, 2, 3, 4, 5, 6, 7, 8, 9. So imagine if I have S here and S here. And then another situation also could be this situation where I have P here and I have P here. So these situations, these are the situations that you don't want. You don't want the first and the last letters to be the same. So how many different arrangements do I have when the first and the last letters are the same? So that means to fill in these spaces right here, I will need, how many spaces are there? There are 7. So I'll need 7 factorial ways to fill in the first one. So I'll have 7 factorial. But you must know, as you fill in these gaps, you are going to use P. So the other 2 letters P will repeat for the top situation. So the P's are going to repeat, so I must remove them. Then I'll say or. So I have that situation at the top, and then I have the situation at the bottom. So I will say plus the situation at the bottom, which is, again, 7 factorial divided by 2 factorial. 2 factorial for the S's that we have to fit in these 7 gaps here. So they are also repeating, right? And this must be subtracted because it's not what we want. So we must subtract this from the total arrangements. So the total arrangements is what we just calculated above, which was 9 factorial divided by 2 factorial, 2 factorial. So we must subtract this, and obviously we'll get 9 factorial divided by 4 minus 7 factorial. Why am I saying 9 factorial minus 7 factorial? You can just put this in your calculator. I'm just trying to simplify it, but you can just put it as it is. You can put it in your calculator. But if I have 7 factorial over 2 plus 7 factorial over 2, it means I have 2 by 7 factorial over 2. Then the 2 and 2 will cancel. Then I'll be left with 7 factorial. So that's why I just said that. But then we can say, what is 9 factorial? 9 factorial, which we calculated above anyway, divided by 4 minus 7 factorial. Minus 7 factorial. So I'm getting 85,680. So 85,680 different ways of arranging the letters in the word happiness and not having the first and last term being the same. Okay, so this is how you calculate it. Okay, moving on to the next question. It says, find the number of different arrangements of the 9 letters in the word happiness in which the 2 P's are together. And there are exactly 2 letters between the 2 S's. Okay. Let's look at this one. So I'm going to look at different situations. So let me start by 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want the distance between the 2 S's to be 2 letters. So I'll place S here, and then I'll place S here. So I can have a situation where the 2 P's, because I want them together. So I can have them together in between the 2 S's like this, right? In which case this is fixed. So once you have this situation, you can treat this as one thing. You can treat this as one object because now it's fixed. It's locked in like that. So I have this situation. So I'll count this as 1. Then I'll say I have 1, 2, 3, 4, 5, 6 distinct objects to be arranged. 6 distinct objects to be arranged. So what I'm going to say I have 6 factorial ways of arranging this. 6 factorial ways because there are 6 distinct objects if I consider what's in the red box to be one thing. Okay, so let's look at the other situation here, where the P's are not in between the S's, they're outside. So I could say 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'll have my P's outside. I'm going to combine them outside, so they'll be here. And then I'm going to have S here, and I'm going to have S here, maintaining 2 gaps in between. So I'll need, how many blanks do I have? 1, 2, 3, 4, 5. So I'll have 5 factorial ways of filling in those gaps, right? And then if I treat this whole block here as one thing, as one object, and then I just shift it like that, then I'm going to shift it 1 time. Then I'll also shift it until like it's here. Then I'll shift it until like it's here. And then I'll shift it there. So I have 1, 2, 3, 4 different shifts of that block. So I can then have 4 shifts. So these are just 4 positions that the block can occupy. So it's not 4 factorial, it's just the different positions that you can occupy. Then after I'm done with that, I want to consider now not shifting the entire block, but just shifting. I just want to shift. Let me select my pen here. I just want to shift the S's. So S's are right here. Right, this is where they are now. Then I'm going to shift them 1 unit to the right. So they will be here. And then I'll shift them again. They will be here. And then I'll shift them again. They will be here. So you can see I have 4 positions that I can shift them to the right. There is another situation. Okay, let me just draw this one in green so that we can explain. So if I put a break here, just put a break there, and then I'll have how many spaces this side? 1, 2, 3, 4, 5, 6. So let me have the 6 positions here. So 1, 2, 3, 4, 5, 6. But you see, I could shift the S's backwards to the left, but maintaining these 6 positions, such that the P's are now to the front of the S's. And then I will have S here and S here. So this is another position that the block can occupy. So then I can say I have 4 shifts for the S's to the right. And then I have an additional 1 shift backwards. So I have 4 plus 1 shifts for the S's. Do we understand this? So 5 factorial ways to fill in the blanks, 4 ways in which I can shift the whole block as it is with the P's at the back. I can shift this block 4 ways to the front. And then if I just consider the shifts for the S's, I can shift the S's 4 units to the front, leaving the P's where they are. And then I can have 1 more shift of the S's where I push them backwards to the left, displacing the P's and moving them to the front. Okay, so these are the total possible arrangements that you have. Okay, so we just have to add all these arrangements. So let me just write everything at once. Let me write everything at once. I will erase here so we can write. So we can say that we have, let me select my pen. So we have 6 factorial ways of arranging these letters when the P's are in the middle. But then we are going to add what happens when the P's are not in the middle. So what happens when they're not in the middle is that I can fill in the blanks 5 factorial ways. I can shift the block 4 ways to 4 different positions. And then I can shift the S's 5 different positions. So this, and then I just need to put this in my calculator. Let me put this in my calculator and see what I get. I get 6 shift factorial plus open bracket 5 factorial times 4 times 5. That should be times 20. So this gives me 3,120 different ways in which you can arrange this. Okay, so that's one way to look at it. But another way of thinking of it would be to say the P's are at the back. So we still have our 6 factorial for when the P's are in the middle. But then if the P's are not in the middle, let's say where they are right now, you could ask yourself, how many ways do I have of filling the gap between the S's? If we go to the way the happiness, you can see that if I take out, now because I must take out the P's, I must take out the S's. And you will see that I will have 5 remaining letters, right? I will have 5 remaining letters. So out of those 5, I need to pick 2. So I could say 5 here and then choose 2. And then I place these 2 letters, but the letters will be different because you can see H, A, I, N, E are all different. So when I place these letters here, they'll be different. So I can swap them. So there'll be 2 ways of arranging them. So I'll say choose them, 5 choose 2. Those are the different ways of selecting them out of the 5. And then once they are in this position, they can be swapped because they are different. So there'll be 2 ways of arranging them. You are done with that part. Then you can say, so I have what? 5 choose 2 times 2, right? But then also, these P's can be shuffled with these 3 blanks because I will treat the P's as one object. And then I have the 3 blanks. Then I can shuffle those 4 factorial ways. You see? 4 factorial ways for shuffling the P's, treating them as one object, and then shuffling them with whatever is occupying those blanks. Then I will have, again, my shift for the S's. So if I shift the S's, I can shift them 4 units going this way, 4 positions, different 4 positions this way. And then there's a backward shift of 1. Because if I shift them backwards, I can only shift them all the way back to the beginning. Because if I shift once backwards, then the P's won't fit. So I will only be able to shift them backwards to start right at the beginning. So this also is another way that can be occupied. So we have 5 valid positions. If you count my red lines, there are 5. So I will have 5 valid positions for the S's. Okay, so I can say 5 here. And then I just need to combine this. So let me put this in my calculator and see what I have. I have 5 combination 2 equal to times 2 equal to times 4 factorial equal to times 5 equal to, then plus the ones up there, which is 6 factorial, shift factorial equal to, same answer, 3,120. So that's another way of looking at it. So there are 2 different ways in which you can look at it. It just depends what comes to mind in the exam, really. So yeah, kind of think about it whichever way, but that's how it is. So we have 3,120 ways of arranging them. Let's look at the next question. The next question says, the 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. Find the probability that both P's are in one group and both S's are in the other group. The moment I see probability, I underline this because you need to be careful not to calculate just the different ways in which you can arrange this or select. You need to calculate the probability. So I will write here that probability is equal to the desired outcomes divided by the total possible outcomes. Total possible outcomes. Okay. So I will need the total possible outcomes. I will need the desired outcomes. So let me do the situations here. So I have 1, 2, 3, 4. I have 1, 2, 3, 4, 5. And then I will have a repeat of this 1, 2, 3, 4, 1, 2, 3, 4, 5. I have a situation where the P's are in the group of 4, and the S's will obviously have to be in the other group. Or I can have the S's in the group of 4, and then the P's in the group of 5. Now, if you look at this, how many ways do you have of picking here? So I will have 5 choose. I want to choose 2 from the 5. After I remove the P's, because I can no longer use the P's in the word happiness, and the S's, I can no longer use them. So I'm left with 5 letters. I want to pick 2 to place here. After I pick these 2, I'm left with 3. So that means here I will have 3 combination 3. Again, the same situation down there. If you want to fill in the first 2 boxes, you have those 2 spaces. You are going to pick from 5 and you want 2. Then you are left with 3. Then you're going to say 3 combination 3. So these are the desired outcomes. But the total outcomes, what are the total outcomes? We want to divide this into a group of 5 and 4, but we have 9 letters. So I will have 9 combination with whatever you want. You can say 4 or 5, it's up to you. But I'll say, let's say 5 combination 4, then times the other group. Oh, so after you pick 4, how many remains? It can no longer be 9. You are left now with 5. So that means, let me select my pen here. Where is my mouse? So that means you're left with 5. So you have 5, choose 5 for the other group. Because out of the 9, you have selected 4. So you're left with 5. You need 5. 5, choose 5. Okay, so you just put this information in your formula that you have already written here. So our desired outcomes are 5, choose 2, times 3, choose 3. Close that bracket. And then we'll say plus 5, choose 2 again, times 3, choose 3. Okay, so, okay, I could have just multiplied by 2 because I'm getting the same thing, isn't it? And then you just divide by your total possible outcomes, which is 9, choose 4, multiplied by 5, choose 5, isn't it? And then you can just plug this in your calculator as you see it. So if I plug it into my calculator, I'll use the fraction button. I'll say fraction button, then numerator, I'll say open bracket. And then I'm going to say 5, choose 2 times 3, choose 3, which you should know what that is. 3, choose 3. And then I will close, and then I'm going to multiply that by 2 because it's the same thing at the top. So then at the bottom, I have 9, choose 4. So I have 9, choose 4. And then if you want, you can plug in 5, choose 5, but that should give you 1, isn't it? And then you just put that in your calculator. The result is 10 over 3. So we get 10 over 63, not 3, sorry. 10 over 63. So this will be my probability, 10 over 63. And as a decimal, what is that? It's 0.159, okay? 0.159. If you want, you can say 0.159 in decimal, but the fraction is more correct because it's not rounded value.